In this video, we're going to talk about how to graph quadratic functions in standard form. So standard form is f of x is equal to ax squared plus bx plus c. This is what you guys are probably most familiar with from our last chapter. So we've already talked about intercept form, which, just if I remind you, is a times x minus p times x minus q. Now the connection between intercept form and standard form is that, well, really all we'd have to do is distribute this form out to get it to look like standard form. So even though they look very different, they still can represent the same function. So now let's take a look at an actual example of graphing in standard form. The most important point on any quadratic's graph is its vertex. This is our turning point, so this is where our graph changes directions. Without that, we don't really get a parabola shape. We would just get a piece of it. So in standard form, the way that we find our vertex is we start by finding the axis of symmetry using this formula x equals the opposite of b divided by 2a. So when we look at our equation, f of x equals 2x squared plus 4x minus 3, we know that our a value is 2, our b value is 4, and our c value is negative 3. So using those values to find our axis of symmetry, we would do the opposite of 4 divided by 2 times 2. And when we simplify this, we get negative 4 over 4, which is negative 1. So we know we've got this invisible vertical line at x equals negative 1 that splits my graph into two symmetrical sides. So to find that vertex, we know it's somewhere on this line. So we know our vertex has to have an x value of negative 1. So we know it's going to be negative 1 comma something. But to figure out that y value, we're going to use our function rule to substitute negative 1 in for x. 2 times negative 1 squared plus 4 times negative 1 minus 3. Order of operations says do the exponent first, so negative 1 squared is 1. And then order of operations says multiply, so we get 2 plus a negative 4 and then minus 3. Now we can just add and subtract in order. So 2 and negative 4 is negative 2 minus 3 is a negative 5. So we know we have the vertex at negative 1, negative 5. Well, now we have to figure out some other points on our graph, because all we've found so far is our turning point, but we need some other things. So a few things that we can do. We can always make a table of values, but we want to make sure that because the vertex is the middle of our graph, we also want that to be the middle of our table. So now I can choose some other points, -2, 0, -3, and 1 for our x values, and I can take any of these x values and substitute them into my equation anywhere next to x. Well, the cool thing about standard form is that I can identify the y-intercept very, very easily. We know that any y-intercept on this line has an x value of 0. So that would be this number in our table. Well, no matter what, when I'm looking at an equation in standard form, if I substitute 0 in for x, I'm always going to end up with that becomes 0, that becomes 0, and I'm left with this c value. So the y-intercept of every equation in standard form is always going to be 0, comma, whatever that c is. So we know that this point is negative 3. So I'm going to plot the point 0, negative 3. Now, using symmetry, I know that if this point is just one space to the right of my axis of symmetry, that I can flip it over and find its mirror image point, which would be one space to the left. So we know at negative 2, I should also get a y value of negative 3. Oh man, I plotted in the wrong spot. My bad. Try again. Negative 3 is what I mean. Flip it over, we get here. Okay, so I know that when I put negative 2 in, I should get a negative 3, which we can, of course, check by substituting that value in. I also want to get a few other points, so I'm just going to take this 1. I'm going to substitute that in for x. So I'm just going to do it right here above this. So we would do 2 times 1 squared plus 4 times 1 minus 3. 2 times 1 plus 4 minus 3, so we get 6 minus 3 is 3. Again, using symmetry, I know that when I substitute negative 3 in, I should also get a positive 3. So now that we have a decent amount of points and we can get a good shape of our graph, so I flip this guy over, we can go ahead and connect our parabola. Connect our points to create our parabola. And there's the graph of the function f of x equals 2x squared plus 4x minus 3. So now let's write down the actual steps. So step 1 was to find the axis of symmetry. And when we have an equation in standard form, it's always the formula x equals the opposite of b divided by 2a. Once we have that, we can find the vertex, and we do that by substituting the axis of symmetry value in for x in our function and finding y. And then we just need some other points on our table. So we can make, on our graph, so we can make a table. Remember, we want our vertex to be in the middle, so whatever this is our vertex. And we can just choose some other x values to the left and to the right of that number. And one thing we want to remember is that the y-intercept for every equation in standard form is always 0, whatever that c value is. So now let's look at this with comparing in real life. So we want to model with a quadratic function. So Anna is practicing a new move at cheerleading where you throw a girl into the air. The equation h equals negative 16x squared plus 28x plus 7 represents the height of the girl, h, in feet, after x seconds. And they want us to know what is the maximum height of the girl. So anytime they're asking for that maximum, they're really just asking us for that vertex because they're talking about the height. So if we think about this visually, we know it's going to look something like this. So they want the highest point, which is that vertex. So if I take an equation in standard form and I want to find the vertex, well, first I have to find the axis of symmetry. So we get x equals the opposite of b, so negative 28, divided by 2 times negative 16. So we end up with negative 28 divided by negative 32, which is 0.875. So we know this is the x value of the vertex, so that's this part right here. But now we want to find the y value, how high it is. So we're going to substitute that value in for x, so negative 16 times 0.875 squared plus 28 times, I'm going to run out of room, 0.875 and then plus 7. So if we do this in our calculator, we're going to do the exponent part first. So negative 16 times 0.77 if we're rounding, plus 28 times 0.875 and then plus 7. And if we add this all together, try and multiply that, we'll get our answer. We end up with 19.25 feet. So the cheerleader went a maximum height of 19.25 feet in the air. Another thing that I could ask you about this equation is, what was the starting height of the girl? Well, we know the starting amount is at 0 seconds, so that would be our y-intercept. So in this case, we would also be able to say that the girl started 7 feet off the ground and then was tossed into the air, made it up to 19.25 feet, and then came back down.